Hello, 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 hello. Let me fix up a couple things here. Everything's a bit chaotic. Oh god. That'll do. Joe's always in transit, it looks like. Always doing something. Why is this so difficult? Okay, that'll do. That'll do. Okay. Ooh, good afternoon, everyone. Welcome to our final lecture. Apologies, I'm a few minutes late. I dropped my water bottle right before we went live, so that was a really good start. I agree, it does feel like summer today. The weather's really nice for our final lecture. How sad. We're all feeling melancholic. Yep. It goes so fast. Melancholic. Sure. Daniel, you're just happy that it's over. I see. Tutors, if they're studying classes, of course they have their own exams. They don't get exceptions. Just I don't have exams. How nice. So, what are we going to talk about today in our final lecture? Again, no new concepts. You've got plenty of stuff that you need to be doing with the assignments and the exams. So, we're going to spend our last lecture together looking at some of the things that we don't cover in 1511 that maybe we used to or that we think are useful that will help you in future courses. We're going to talk about future courses, even future careers potentially, and we've got some surprises in the last part of the lecture, which will be really fun. Like always, thank you to Tammy and Patrick for helping out with the lecture chat. Another cracked Kahoot, yeah. Maybe someone needs to write a Kahoot for me. That would be good. Yeah, this lecture is basically out of the course. Industry experience, we can talk about all of that. We can just have a chance to reflect and think about what's coming, where you've come from, what we've done, and where we're going. I don't even have Kahoot Premium, so cool. So let's get started with. Move that up a bit. With some stuff that we don't talk about in the course anymore, that we used to talk about. The first of these topics is called recursion. And basically we can go into this as little or as in depth as you'd like. So you guys, as always, are driving the pace and the content of the lectures. So who's heard of recursion? I know some of you have even used it in the course on your own volition. And to someone, if you do think you know what it is, do you want to put in the chat what you think it is? You've heard it thrown around, yep. That sounds right. Recursion is your best friend. Does struct node count as recursion? Sort of, but not quite the context when I'm talking about it. When a function calls itself, yeah, that's pretty much, the very practical answer of it. So recursion, like I've said it's right here on the slide, calling a function from within its implementation. What does that mean? It's basically when a function calls itself. and passes in some data. So why do we use it, and why don't we talk about it anymore? So recursion can help solve certain types of problems elegantly. When I say elegantly, what I'm talking about is maybe less lines of code than other solutions would require. However, recursive solutions are more difficult to get your head around than non-recursive solutions. And I'll explain a little bit about why that is. They can cause problems if you don't really think about it correctly. The reason for that, again, I can explain. So they're useful to know about, especially conceptually and from a computer science lens. However, personally, in my software engineering experience, be it industry, research, or anything like that, I avoid recursion as much as possible, and I tell others to avoid recursion. Sometimes it can lead to some pretty nice and cute solutions to problems, but more often than not, I think they create more problems than they solve. But why don't we get our text editor up? And oh, I see. Disable that. Get our text editor up. We'll just go to desktop. Sure. Okay, whoops. Actually, make the 1511 final lecture. Okay. Let's make a new file called recursion.c int main void. Okay. Oops. And I think a really nice I thought I turned that off. To demonstrate recursion. Turn 0. My desk is a little high. .h. I can't spell. All right. Let me read the lecture chat quickly. Interesting. Okay. Yeah, length of a linked list is good. Let's do something simpler. So a really common and nice sort of demonstration of recursion is calculating the factorial of a number. So we're going to write a function called factorial. It returns an integer, and it accepts an integer that we'll call n. When is the practice questions for this week due? I think by the end of the week, I think. Monday next week. So this function, we want to calculate the factorial of a number. And the way we can do this is actually quite simple. So first of all, we need to, whenever we have recursion, so a function which accepts an integer n and returns an int, whenever we use recursion, we need to handle edge cases. Actually, maybe I'll put that down here. So this is the first thing that causes problems with recursive approaches. So basically, if we're, or just as a recap, can someone put in the chat what we mean by when we calculate a factorial? Exactly right, Nikhil. So just to make sure we're all, just fresh with it, I'm sure you all are familiar. 4 factorial would equal 4 times 3, oh my god, times 2. I guess we don't need to times 1, but technically times 1. So we take an integer and we multiply it by the subtraction of 1 of its value. Right? So we could solve this with a while loop pretty simply, subtracting 1 each time, blah, 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 blah. But we can also solve it recursively. So what I'm saying first is we need to handle the edge cases. So we need to handle the case, who pointed it out? Like Daniel or Nikhil, that when n is 0. So if n is 0, and you'll understand why we need to do this in a second, we just return 1. And that means we sort of exit the function. Else, we return n times the factorial of n minus 1. And that is actually the fully complete solution to factorial using recursion. And if you look at it, it seems really strange. It's like, where's the actual calculation here that works? Right? But when we run through it, we'll see that it does work. And to prove that it works first, why don't we actually do this? So we can say int n is equal to, let's say 3, print f percent d factorial of n, right? Where's our little terminal? Is this looking okay for the lecture? So first we need to compile it, gcc, recursion, dash data program, that looks good. That compiled okay, which is a good start. And we can run the program. Okay, I didn't put a \n, that might be nice. But what we get here is that we get the value 6 printed out. And if we think about it, I mean, that's the correct value. 3 times 2 is 6, times 1 is 6. And that is the factorial of 3. We can increase that number, and we get the factorial of 4. And this is obviously a recursive, what have I got here? A recursive solution to the problem. The reason we need this guard here that n is equal to 0 is because we call factorial subtracting 1 by n every time we call it. So actually this is the line that returns the final result from the function. Only this line. What this statement does is it continues to execute, create a new stack frame of this function and continue to execute it. And someone asked, is factorial part of... No, we wrote this function. It's called factorial. I could call it, Jake's recursive factorial. And that would work just the same. Yep. Cool. So I think the best way to understand how this works is, drum roll, to whiteboard it. Okay. We need to get the code on the side. That should do it. And we'll get this little thing here. Ah! Calm down. Figma. All right, so we have main here. Maybe that's a bit big. And we've got factorial. Let's just turn this back to factorial so it's easier to read. We're not whiteboarding, we're figuring it exactly. Final whiteboard, I know, it's heartbreaking. All right, so in main here, let's do something like this. We have this number 4, which is n. Let's just make it a bit smaller. Can we read that okay? Maybe put this here for this. All right. That's all we have in main. That's the only function, the only variable. So it's pretty straightforward. Then we have this factorial function, which we call here, and we pass in n. N is 4. So a copy of n gets made and passed into the function, right? That's the input, and it's also called n. It should be a lowercase n, right? And then we'll run through it sort of line by line. So is n equal to 0? I mean, the answer is no, so it doesn't do that. And it returns n, so 4, multiplied by factorial of n minus 1. Now, factorial is a function call. And what happens when we call a function in C, or in any programming language, really? What happens when we call a function? Excellent, Matthew. We create a new stack frame. Just like we created this stack frame. In fact, this is sort of factorial stack frame 1, right? We create a new stack frame. But we did not pass in n of 4. We passed in n minus 1. So we passed in 3 here. But it's n times the result of this stack frame. So what we need is some sort of way to show the output. How can we do that? Maybe what we'll do is have like a result here, like the returns. Return, for example, there. So this is going to return 4 multiplied, right? N, 4 multiplied by, I need to make this a bit bigger as well, multiplied by the result of this. But we can't complete it yet because we need to evaluate this stack frame. So this stack frame starts at the top. It accepts an integer called n, which is 3. Is 3 equal to 0? No. So we do it again. We make a new stack frame. This isn't a pointer, by the way. Don't get confused. It's just it's just the arrow is a nice way to say that we're waiting on the result. Maybe just make this a bit smaller. This gets passed into 2. And this is doing 3 times, waiting for this. This is 2 times one more stack frame. And this is stack frame 3. It'd be nice if this, whatever. This is 1. In fact, I think if this was n equals 1, this would be fine as well, actually. So we can probably stop it there. So we come along here. This is still waiting for this result as well, right? So we call 4. It says 4 times this. This is 3 times this. This is 2 times 1. And this is saying, okay, is n equals 1? So this is my exit condition. That is true. So it returns 1. This does not return n times something. This just returns 1. So it returns 1, okay? Which means the function ends, it's returned. So this has gone away. The number 1 was returned. So this is 2 times 1, right? Which we can finally evaluate now. So this is going to just be, of course, 2, which means this stack frame disappears. So this is 3 times 2, right? Which means we can calculate that. So the value 6 is going to be returned, which is returned here. right? So 6 times 4 gets returned. And finally gets assigned, or we just print it out. So we're just going to printf 24, basically. And that stack frame gets deleted. And that is how the recursive solution works. So it actually builds up all these stack frames, right? Until the final one can calculate an expression, and then it trickles down the values all at once until it distills down to this final value. Now, some of you are sort of pointing out the risk with recursion. So for large numbers, would this not take a long time? Look, creating a stack frame, yes. The answer is yes. This is, I think, always going to be slower than just having a while loop, for example. Like I said, the benefit of it is having an elegant solution. You know, you don't need a while loop, and you don't need if, conditions and things like that there. The real problem with recursion isn't so much the speed. I mean, we're running on such fast computers that 30 recursion is not going to be a problem. The real problem with, if we go back, even for a pretty small value, n being 4, and this should be 4, how many stack frames have we had to create and keep in memory all at once? Remember that while we're computing the solution, these stack frames all exist in memory, right? It's not like we call one and then get rid of it and call another one and get rid of it. These all have to stay in memory all at the same time, which means we need to store enough memory in, we need to keep, for example, 1, 2, 3, 4, 5 integers in memory just for this solution. Whereas we weren't doing it recursively, we would only need 1 integer in memory. And that's the problem we come across with recursion, is that we call a function one too many times, we create one too many stack frames, and we have a stack overflow, which is famously where the name Stack Overflow, comes from for the website that I'm sure you've all used many times. So if you don't, for example, if we didn't have this here, we could simulate it ourselves. Oh. Right, if we just returned this, for example, you can see we actually come across a problem quite quickly. Because we just created one too many stack frames and ran out of memory, basically. Although that happened very quickly, so I'm not sure if that was the exact thing that happened there. But I think it is. Because it's going to be a memory-related issue, Nicole. Another thing to think about with... So, as a little anecdote... Oh, you didn't see my... Yep, thank you. A little anecdote. I was doing once a coding interview for... I think it was for Google. And their problem was to write an algorithm to... I think it was to traverse some sort of tree structure. Like maybe it was like to pass command line arguments, and then it was to actually create a tree structure from some data input. So I think it was like, here's a number of nodes we want on the tree. Here's the data to put in them. Go create the tree. And the way that those interviews sort of work is like you write it, and just like your assessments, right? You get some auto tests. But there's secret hidden auto tests that they use to see how good your solution was that you don't get access to. And you only see the result of it when you submit the file, right? Does that make sense? Just like you do with your assignment and the exam, for example. So there's some public auto tests and some private auto tests. And you could say maybe they're being evil or tricky or something like that. But so you write your solution, and when people do these sort of problems, like creating a tree, which is a recursive data structure. Just like a linked list is a recursive data structure. Someone mentioned earlier, are we doing something with recursion when we have a node pointer that points to a node? Yeah, that's a recursive data structure. Like if you think about it, it's a node that points to a node that points to a node that points to a node. Just like this is a function that calls a function that calls a function that calls a function. And so when people write binary tree solutions, oftentimes they use a recursive function to go through the tree or to generate the tree or something like that. And what happens, so they give you all the auto tests and you write your little recursive solution and it all works. And you're like, oh, I'm the best programmer ever. Google are going to give me this job. I'm going to make gazillions of dollars and live in a penthouse apartment. And then you submit the solution and the solution is correct. There's nothing wrong with it. All your edge cases are there. We thought about it all. You submit the solution and you don't get full marks on the problem. And what they do is in their hidden auto test, they just have a big tree, lots of nodes. And what happens? You run out of stack frames. The tree is just too big. The way that you're building it, like we demonstrated with just this small example, is that you need all the stack frames to exist in memory at the same time, right? So you run out, just like we ran out quite quickly here. So the solution, and how I solved it, was to just not use recursion. I just literally made a while loop. Yeah, there goes the penthouse time. Exactly. But I didn't do this. I didn't do that. I didn't use that solution because I knew that there must be something more that they were looking for. So all I did was use a while loop. And that solves the problem because you don't have to create the stack frames. You might still use more memory, but that's fine. And there's other ways. You could still, I think, thinking about it just now actually, there's ways to solve the problem with recursion without running out of stack frames. So if you think about building a tree, you could just build segments of the tree in batches, right? So it's like, okay, I'll build these nodes, then I'll kill all my stack frames, then I'll build these nodes, and then I'll join the tree together. My point is, why bother? I mean, just use a non-recursive solution and you'll be okay. So personally, look, I'm sure some theoretical computer scientists and algorithms people might say, shut up, Jake. But anytime you want to use recursion, if it's not out of self-interest, just use a while loop. I think I'm right in saying this, but I'm putting a caveat. There's no solution. So recursion can't solve anything that a while loop can't. Yeah, was that correct? Recursion doesn't give us any magical powers. So when in doubt, use a loop. Anyway, that's recursion. I have another recursion algorithm that we could show off that's pretty cool. Do we want to see it or do we want to move on? Yeah, exactly right, Cyril. Yep. What are all the questions? Sorry, I'm in a... Okay, I didn't continue the interviewing process, but I didn't get rejected. Does that make sense? But I'm not living in a penthouse, as you can tell. Yeah, the non-recursive solution is maybe harder to write. You're right, Daniel. It might be more lines of code, more opportunities to stuff up. But yeah. Ackman's function. I need to Google it. Ackermann's function. Let's get a simpler explanation. Simplest and earliest discovered examples of total computable function that is not primitive recursive. All primitive recursive functions are total and computable, but goodness. n+1, okay. Look, maybe. But I bet you'd be able to. I didn't say no to Google. I don't think I'm too cool. Yeah, they just want us to play RuneScape. I mean, that would be a fun final lecture. Oops, what's happened to my browser? How to write Ackermann's function non-recursive? Not quite. Okay, so it's not as efficient, maybe, but definitely non-recursive, using a stack. Cool. It looks possible, but maybe not as efficient. But I'm not familiar with it. Actually, speaking of Google, one of the weirdest things that ever happened, well, not really, but I was, I think during my PhD, I was writing some Python code, some AI stuff. And I was like, it was, you know, when you're just working a long day, it was like maybe 3 a.m. I'd been writing code all day and, you know, Googling lots of things, all these Python libraries that are just arcane and stuff. It was like 2, 3 a.m. And then my Google homepage, like the whole homepage just fell back. Has anyone seen or has this happened to anyone? I Googled something and the whole homepage fell away. And I was like, this is it. This is where I have my breakdown. It's all over. And it was like a Google hiring challenge. Yeah, it's pretty cool. And then like you had to solve these problems. Yeah, this is it. I had a good run. Yeah. No, it wasn't an Easter egg. It was like they had targeted people based on what they were Googling to interview for them. Yeah, it was like this level thing. That was it. I think I got all the way, Cyril. But then I think that might have been the same time. But yeah, it might have been. Maybe I made it all up. I should log back into it one day and see if it was there. And then I think if you solved all the problems, they like fast tracked your application. Something like that. And then like a bunch of people were Googling like, how do I get it to pop up? I want a job at Google. And then people were like, oh, I don't know. Yeah, Foobar. That's what it was called, Audrey. But yeah, it wasn't even an ad. It was like my whole Google homepage just disappeared. It was really strange. It like 3D fell away from the screen. It was pretty cool. Good marketing from Google to get engineers. Another cool recursive solution. Has anyone heard of the Towers of Hanoi problem? Yeah, it was a very backrooms thing. I won't write the whole thing. I already wrote it just before the lecture. Int main void return 0. And then I think towers. Let's go 3. Using B. So the Towers of Hanoi, we're probably not going to need Figma again. For anyone who's not familiar with it, basically, how am I going to do this? You have three pillars. You know what? It's probably going to be better just to Google Towers of Hanoi. It's a toy. It's a little toy. Let's make sure these images are safe. So I think it was an old toy. You have, this is a good image. You have these 3 pillars with the discs stacked like this. And the goal is to move all the discs to another pole, for example, the C pole. But you can't put a bigger disc on a smaller disc. So you have to move, for example, disk 1 to B, move 2 to C, and then 1 back to C so that you free up the auxiliary pole or the spare pole B. And actually, the solution to this is extremely recursive because you do the same thing, like you pick your spare pole, you move a disk, you move a disk, you move a disk, and you get it over. And so, of course, we can solve the problem recursively very easily. So with this procedure called towers, it takes the number of disks, the pole that the disks are stacked on to start with, the pole that the disks you want to move to, and some spare pole that you'll use for the pivoting. If you're at the last pole, you're done, basically. Go home. Otherwise, take the pole at the top and move it from the from the from pole to the auxiliary pole using the 2 pole as auxiliary, and then you move it back to the spare pole to solve it. And you keep doing that over and over. I didn't do a good job of explaining that. What did I call this? Towers.c-o to program. And these are the steps necessary to solve, to move all the disks from A to C in order without stacking them. I mean, we could, I don't know, we don't really have the time to draw it out, but yeah, and of course, if, the number was really big, well, not really big, but bigger. I mean, that's still solved pretty quickly. But these are the steps you could follow and solve the problem. What exactly is to and from? So you've got 3 poles, A, B, and C. I mean, we can look back at here. This is the same thing. 3 poles, A, B, and C. You start off with them all stacked on A. You want to move them to pole C. And the 3rd pole that you're not using is your auxiliary pole or your spare pole. And so these instructions would tell us, okay, the first step is move disk 1 from A to C. So we would move disk 1 from A to C. That would put it there. Then we move disk 2 from A to B. So that goes there. Then we move disk 1 from C back to B. So that smallest disk would go on top of the 2nd disk on B. Where did we define them? Here, basically. There's a nice simple, yeah. With that, really, if I had the toy, that would be really cool, because then I could just do it. I should do that for a future lecture. Damn. If we do it with 5, it's still a lot of steps actually, but it would visualize for what we have here. If anyone's got like an interactive one that I could actually move the disks around, I can demo it, but I'm not sure if I'm not going to start looking for one. Cool. I'll put this code up on the lecture repository. Again, recursion is not tested in 1511 or examined. It's just interesting stuff that we don't cover anymore. Oops, Patrick's come through. Okay, awesome. Okay, that's cool. Okay, let's see if this works. I think it works, but let's clear that. Let's just do 3. Otherwise, we'll be here forever. We're going to call this A, this B, this C. We want to move them. Oh, I didn't compile it. I was going to say that was way too many. All right, so move disk 1 from A to C. Disk 2 from A to B. Disk 1 from C to B. Disk 3 from A to C. That's this one. Disk 1 from B to A. Disk 2 from B to C. That's this one. From B to C. And disk 1 from A to C. Beautiful. And that's it. We went from A to... well done. Cool. And we could, increase the number of disks and solve it there. I mean, doesn't it feel sort of magical that this... Like, it doesn't feel like the solution is encoded in this function, but it is. And the reason it works is because every time you solve it, you do the same thing. You move the top one, to the destination pole. You move the one unit. You need to swap them, so you need to have the auxiliary pole, and you just do the same thing over and over and over. Here's the link if you want to have a play yourself. And maybe a nice little challenge would be to solve this without recursion and seeing what it looks like. Yeah, there's only one optimal solution. I don't know if it could be faster, but I'm not sure. This is breaking me. It seems like the solution is too simple. The key is that basically there's only one way to solve it, and it's just that the number of disks correlates with the amount of times you need to do it. Yeah, well, there's only one solution, Daniel, if you're going from A to C, I think. Okay. All right, what was next? So yeah, recursion, it's really cool. It's fascinating. It's dangerous. Don't use it. Okay, command line arguments. All I've got here is very useful, just like these slides. All right, let's do another example. I meant if you go from A to C via B. Oh yeah, I guess so. Yeah. Okay. We don't need that. We don't need that. Let's make a new file, save it, command line arguments.c. Once again, int main, void, return 0, beautiful, include standard lib. Include standard IO. What am I doing here? Okay, so this is a really cool one. So unlike recursion, this is an extremely useful concept. So when we have functions, double integer int x, x equals x times 2. Right? We have this procedure or some function, and it accepts a parameter which lets us drive what that function does. It's the input into the function. And without parameters or arguments, our programs would be extremely boring, right? I mean, often, if you think about it, unless you had some sort of randomness in the program, our programs would do the same thing every single time we ran them. But we only have these parameters and arguments for functions and procedures so far. But actually, it's possible to provide arguments to a program itself. And the way you do that is by having arguments into the main function. Oh, Joe, be careful. So this is really cool. In fact, you've been using this every time you compile a program. Because if you think about it, I called GCC towers-o program. This is input into the GCC program. These are arguments or parameters into the GCC program. So how do we do it? It's not as simple. Okay, well, it is simple. We can pass in an array into a program. So into the main function. In C, if we are passing an array, we also need to pass in the size. So we need the int argc, the argument count, and we need an array of characters as an array. So this is an array of strings basically. And an array of strings. Because if you think about it, you can only pass strings into via the command line. You know, this is a string called program. This is a string called -o. This is a string called towers.c. So if you want command line arguments in your program, you pretty much always only put this exact syntax here. So the argc int and the argv character array, or the string array. Yep, I'm definitely not an AI, but that's cool. Okay, so then we can print f %d \n, and then we can print, let's just print argc and see what that does. So if I compile, you know, -o to program, and then I run program, we get this one printed. I mean, we're not doing anything with this. Let's just get rid of that. But we get this one printed out. And the reason for that is there's one argument to the array, and it's the actual program name. So yeah, program count. So sorry, argument count, argument vector, or the vector is just an array, usually with some extra stuff. But I don't know why historically it's called a vector in this example and not an array actually. But I think it stands for argument vector. Yeah, it's a list of the arguments. The pointer is saying that it's a character pointer. So it's a string array. Okay, so by default, when you execute a program, it's got one argument count and it's the name of the program. So we can actually print that out. Is that right? Yeah. argv, whoops, and we'll print out just the first one because we know it's going to be there. We compile it, we run it, and you can see it's the actual path. You know, I called /program. That actually gets passed into the program. So far though, we've just been completely ignoring it and not doing anything with it. But it actually gets passed in, which is quite cool. So what's the next step to this? I mean, so that's pretty cool. But I can pass in, you know, extra things like Jake is not an AI. And now we see two things were passed in, which means if I print that out, whoops, and I compile it first. Okay, that didn't like that. Oh yeah, I didn't. There we go. I pass in some string and it gets printed out as well. I guess maybe that's why it's called a vector, because it didn't crash, which is quite cool. Anyway, so what we usually then do is we say int I equals 0, you know, while I is less than arg count, and we can just printf. Oops. Compile it. Jake is not an AI, and we get to program. Maybe we do something like this. Program, Jake is not an AI. And if we run that again with a third argument, neither is Tammy, then we also have access to that. And we could just have more and more, and they all get passed in. I'll only spare you if you do your my experience result. Otherwise, you're going down. Cool. So So why don't we apply this? So what if, right? Look, we have this factorial program, but this n was always hard-coded. We could make it do scanf, but it's not really necessary. We could pass in argc argv, and we could say, that's really annoying. We could say that int n is equal to argv of 1. And first we should say if argc is less than 1, return. I guess that should be less than 2. Yep. So if there's not enough arguments, we don't continue. Otherwise, there should be an argument. So we're going to say int1 is equal to that first argument. Remember, argv0 is the name of the program that got executed. And then we can just call factorial there like that. And I think... Okay, no, we can't, because n is an integer, but argv is a string. So c string to integer. There's the atoy function. So like this. And I think that comes from, I think just standard lib. So that should be okay. Let's compile gcc recursion -o to program. Oh, okay. That just wants to, an integer there. We run that. Okay. That returned nothing because I didn't pass in. In fact, I can probably say, oh no, you didn't pass in an argument. Right, but if I pass in, for example, 4, oh, we get the crash because we didn't handle the edge case. If n is equal to 1, return 1, else we do that. And we get the factorial printed out, which means I can just run it again. I don't need to recompile or do scanf. I mean, isn't that cool? What are you... Chat's going nuts today. Jake is revealing how he remembers stuff. Don't you have to return something in line 13? Oh, I guess that's all moved around now. Is there a way to call other functions in the program from the terminal like you can in Python? Is there a way to call other functions in the program from the terminal? You might need to explain that again. Jake is making mistakes to convince he's a human. I'm a deep fake. That would be pretty cool. You mean if you open the Python interpreter in a shell, go higher? We're going to run out of stack frames. Oh, there we go. We integer overflowed here. That's pretty cool. Now it's just not doing well. It's returning 0. There we go. We ran out of stack frames there. But it wasn't able to store the number was too big in this case, so it just can't store the number. And then at this point, it actually ran out of stack frames and broke. Remember, in this example, it's only got one integer on the stack frames, so it's not very big. But if you can imagine if that was a bigger piece of data, it would break. But I mean, if you also think about it, I mean, this is so powerful because then I could pass in like the result of other programs could go as input into other programs, and so we can chain programs. And this is how Unix does a lot of things. I think we've done multi-file programs, didn't we, Matthew? I think we had a lecture on it a few weeks ago. So yeah, command line arguments. Anytime you run a command line program, like GCC is a good example, there's 3 arguments getting passed in here. And the program basically has some code that can determine, if there's 3 arguments and the second one is a -O, I should be doing this, and the thing that comes after that. So, I mean, it takes a lot of work to sort of put these things together. But for simple cases where you know that you might want to be changing the value all the time and you don't want it to be coming in from the user at the terminal because you're going to be sitting there waiting, argument parameters are the way to go. They're super useful. We could do the same thing with the towers of Hanoi, for example, with the numbers. And we could even read in the A, C, and B, so we could tell it which towers we want it to move from and to, for example. I feel like you can use scanf fgets instead of command line arguments. No, not always, because scanf requires a human to enter the value. Command line arguments, like I was saying earlier, these values could be coming from other programs. I mean, maybe that could be a really cool thing to demonstrate. Atoy is I've just forgotten. See, I'm human. Okay, alphanumeric, string to integer. Oh, I know, it's ASCII. It's ASCII. Okay, so I just wanted to show you, I think this is actually a cool, let me see if I can do this. So let's just go program1.c int main void return 5. No, hold on. Let me just check something really quickly. Okay, so what we can actually do, printf 5, I think this will do it. So program run prints 5, and then let's compile program1.c out to program 1, and then recursion takes in a number. So I think we should be able to do program 1 and pass the output to recursion. No, I think I called that program. No, I didn't. Oh, actually, I didn't pass an argument. I didn't pass 2 arguments. Well, let's just say if that's 1 and that's 0. Is that going to work? Compile GCC recursion -ar to program segmentation fault. Excellent. Print f. Let's just print that out to see what's getting passed in. Yeah, I might be missing something. Oh, what have I done wrong there? Oh, yep. Yeah, I don't have DCC here, unfortunately. It doesn't like... Program 1 should be printing 5. Does it need... I thought you could just pass it. You can use xargs to command... Blah, blah, blah. Do I have xargs? Although this is saying one solution is to do that. Okay, it doesn't like that either. Yeah, command line args. How do I get the output of a... How do I get the standard output of another program? Oh, I just wanted to show it with command line args. I thought you could do it. Although we could also do that. Yeah, but I mean that's not working either. It feels like it's speaking a different language. I thought you could do it. Okay, we can try that before we move on. You're saying like that? To expand it? Okay, that didn't complain, but it didn't print anything. Let's try. Oh, I didn't compile it. Oh no, I shouldn't need to. Nope. This is chaos. Try program 1, pipe to xargs, program. That's what I tried and it wasn't working. I'm just reading something, guys. My last attempt. The programs should be called program. Actually, that's not a bad thing to check. What is program? Did I compile the wrong thing? No, that should be recursion. But we'll compile that to recursion. Okay, we'll try this straight. This should now be recursion. Okay, that worked. That worked. Maybe. Why is it doing 5? Printf. If I get rid of this. Okay, yeah, no, that is the actual argv. Okay, I think that's working. This is a whole... So if argz, that should actually be less than 1. I think we need to... Let's just ignore that for a second. Passes in 5. This prints 5. No, I don't think that is working. Is it? Shouldn't that still... And I don't even know where that is coming from. I don't even think it's here. Yeah, it's not. Yeah, it's the wrong way around. Sorry, I know we're really, we'll do, yeah, okay. Is this what you reckon, Trey? Correct. Oh, that, yeah, that doesn't make sense that. Trey program. Except I renamed program to be Recursion. It's not program, I'm like that. Look, maybe we'll try. Trey and I or someone will figure out this out in the in the lecture break. It's definitely time for the lecture break anyway. It worked? I don't think it worked because it should be doing 5. It should be doing 5. So yeah, it's okay. Anyway, we'll sort it out. We'll come back with a nice working solution after the break. This is all just to convince you that I'm not an AI. Okay. All right, let's take 10 minutes, 5-10 minutes, come back. Yeah, but the 5, it should have been 5 factorial, which would have been a greater number. Okay. All right, we'll see you in 5-10. Okay. Don't look at my Spotify. Have some music here. Okay, we'll do this quick because then we've got the final 30 minutes. Yep. TV reveal. Okay, oops. Okay. I share the playlist all the time. Oh, again, it's coming up. Today I used a different one. Okay, we good to start the Kahoot, or do you need a few seconds? Oh my god, there's a lot going on. Okay, and while we do this, this is our little surprise. Hold on, I can't hear you yet. Can you hear me now?
I can hear you.
Okay, can they hear you? Can people hear Tom? Oh god, I can't tell you how many windows there are.
I can't see anything in the chat yet about us, but we'll find.
Oh, hold on. Talk again?
Hello! People could say they can hear us.
Oh no, they can hear you. Can you hear? Yeah, okay. I think that's okay. Oh my god. Turn Tom up.
Yeah, I'm very quiet. I'm listening to the loop back.
Okay, let's start the Kahoot. Let's bring you in. Oh god.
This is really going to be a Kahoot of a time.
Okay, we can kick Tom now. Nice chat.
Up for puns.
Is this working? Oh my god, this is chaos.
I'm not turning on the YouTube sound because I'm going to from the echo, I think, so maybe not a great idea. Turn Tom up, turn Tom down.
Yeah, they can hear you. We're just a bit quiet, but it should be fine.
I think when the music's off, it'll be better. All right, well, come on, you guys need to. You need to play as well. What are the answers? Can you see? Wait. Oh no. Oh god. This.
Find the
Oh, no.
SMS program.
What if I share my screen? Oh no. Now you're gone. Now you're back.
I've got the stream open, so I can see both.
Yeah, but there's a delay, right? Crazy how the tutors are real people and not just names on the screen.
Well, apparently I'm already.
Okay,
So
I didn't pay attention to the question, but it looks like 20. You mostly got it right. Well done. Who's on the board? And now, who knows? Hayden Smith, Shrey 7. Oh god, chaos.
I'm smashing it.
I find it funny that they increment, that whoever Shrey is increments the number every time. All right, which special characters can be used to separate two words of a variable identifier name? Okay, this one's easy. They're all AIs. Yeah, that's chat's new conspiracy theory. Yep. Oh my god, I'm so proud. 100% correct. Well done.
Nice.
Although I think we've had that question for like every Kahoot.
Wait, bitwise operator.
Oh, whoa.
Well, we're looking forward, guys. We're looking forward. We don't need to cover it.
Yeah, this is actually covered in COMP1511. So
That's
we
right.
already studied that content.
That's right.
Yeah.
It's all right. How quickly can they Google? Yeah, the total guesses here. What a nice parabolic curve we've got here.
Wow. Nobody likes.
To be honest, I had no idea. What's that operator? Or is that not?
Bitwise not.
Yeah, okay. That's shift. Yep.
Right shift. Yeah. So bitwise operations are basically operations that you can do to change the internal representation of a number. So you'll see that in COMP1511, which is core for like most people here, I'd imagine.
I think I'll just put your volume up as well, by the way. They should hear you a bit better.
Yeah.
But yeah, it's like it does, like, it checks the actual bits behind the representation of the value rather than the representation of the value itself. It's pretty cool. Find the output of this program. Oh god.
Well, it's on standard output, so it's on my terminal, right? That's the answer.
Yeah, I found it. It's
What?
on my screen.
Is Shrey
It's
playing
X.
that?
I'm pointing to it.
Yeah, we found the output when you press.
Oh right, yeah.
Good job, Tom.
Should be
Thank you.
evaluate the output. I'm not even. What is this? X is 10. Is 10 greater than 10? No. Is it equal than greater? Yes. So 10 adds nothing. Oh yeah. Cool. Well done to 20 of you. Is Shrey
Evil.
playing the Kahoot? Yeah. I don't know if this is Shrey, but.
No, this is not actually me. My hands are empty.
I'm trying to play, but everyone's beating me, and it's really annoying.
Well, yeah. Okay. Find the out. Oh, what's the output of this program?
Find all the style mistakes too.
X is
Extra
22.
fun.
Oh, this is the dodgy one we had yesterday. You've practiced. Yep.
I need my glasses so I can be like, actually,
Yeah.
it's.
Well, what's
yeah.
the answer going to be?
Well, once everyone's selected the answer, then we can.
Oh, he's panicking.
Yeah. Tammy is
What's happening
calling me
now?
apparently.
Getting a new call.
We're starting up a second call.
Oh, because Patrick.
I'll answer it.
Okay, there we go.
Hello.
Is everyone? Hello, we got Patrick as well now. Is everyone
Yeah.
else joining? Okay, well done.
The other two has to join this one.
Oh no, this is. I need to turn off one of these echoes.
Yeah, this is chaos. What's the output of this program?
So good.
Okay, there we go. Yeah, I didn't think that was going to work. But anyway, what's the output? Okay, what's going on here? Oh, we had this one yesterday. Oh, I'm sorry. But it's a good one for the tutors or admins if you didn't have a look at it. That's not that good. Although the music is
I can't
awesome.
just see the screen, so I can't answer
Oh,
anymore.
I didn't share it.
That's the only company marks. It's not because I had no idea what the answers are. Thank you.
Oh, this is
Yeah,
a
the
fun
music
one.
is sick.
This is the evil one. It's good.
Alright, we don't need this much time. Yep, well done. But they had this one yesterday. See, it's good practice.
Are you guys listening to both the Teams feedback and the YouTube feedback? Because
No.
Yeah,
No,
you should
no.
mute
I've been
YouTube.
trying to decide which one
Mute
to touch.
YouTube.
Yeah.
I don't know which
Yeah.
one's more.
All right, this will be the last Kahoot question, and then we can have a chat. So, what's the correct value to return to the operating system upon successful completion of a program? You've been writing this since week 0.
Yeah, I think it was in the first lecture actually.
Yeah,
what we put
I
here.
think so. And I take it Ben can't be with us.
No,
So,
Ben is
recovering.
not feeling well.
Yeah. Yep. So it should return 0. What was blue? 1. You can return 1, but it indicates there's an error. Okay, now what
And
we
harder
want to
in
do
all of our programs.
is end the Kahoot. The Kahoot music's really next level. Who is it? The final lecture, top of the podium.
Obviously me.
Shay. We gotta have a word about this. You can't keep dominating Kahoot every term.
Where's the prize?
Who was Shrey? Someone's got to tell me who it was.
It was Cyril, apparently.
Who was it?
Yeah. Cyril.
Ah, Cyril. I didn't know that. I might have just missed it. Oh, that was chaotic. Although I missed the music now. Maybe we can.
We need
put
some lo-fi beats
Yeah, maybe we can
to
do
accompany
that.
our conversation.
Like really quiet. Does that work?
Yeah,
All
so
right.
just cut over the top.
So
That's okay.
to round off the final lecture, we thought it would be really fun to get some of the people in that make this course possible. So of course, 3 of 4 of the course admins, Tammy, Shrey, Tom, Ben's not well, so my cam's tiny. That's okay. You've seen me all term. And then we've got Patrick, who helps with the Wednesday lectures, and Noah, who helps with the Tuesday lectures. But I mean, as you all know, it takes a village to raise one 1511 child, so there's many others that that go into it. But why don't we have a little fireside chat to round off the final lecture? The theme of the lecture is looking forward, so why don't we just start doing that? You guys can ask questions about sort of the future of computing at UNSW, CSE, courses, internships some people were asking about, which I know many of you are in right now, have lined up, have already done, and all this sort of stuff. So why don't we just do, you guys can see the lecture chat, can't you?
Yeah.
Cool.
In fact,
I
hold on,
we've
to
already
make
got-
this a bit smoother,
already got a question.
give me 1 second. Let me share the lecture chat window, so that'll be quicker.
Yeah, cool. I mean, there's already questions, so I guess we can start with that one from Jacob. Jacob asks, at what point do you think we should know what to do in career-wise in our comp sci journey? And my answer to this is like, there is no point. You can like get the end of your degree and still not know what you want to do. Hell, I don't even know what I still want to do. I imagine Jake and Tammy also still don't really know what they want to do in long term. It's more about finding one thing that you semi-like and like playing around with it. See how you go. Like investigate different things, different options. I've done a bit of everything from like websites to mobile dev to like research to AI. It's like literally played around with so much different stuff that I found interesting. And I'm sure Tom and Tammy can sort of speak the same as well.
Yeah. One thing which I'd add to that is uni is a really good opportunity to try a lot of different stuff. And so like, as Shrey was saying, there's lots of different courses for lots of different things. But the other thing is like, when you leave university, likely what will happen is that you will have 1 or 2 or 3 job offers, or like 1 or 2, 3 different paths you can take. So it won't necessarily be about like knowing exactly what you want to do with your life. It's okay if what ends up happening is like, you know, through some friends, you found this one opportunity and maybe there's another opportunity where you did an internship. It'll just be like, pick between those 2 options. And that's a much simpler choice. And then you've got plenty of time to sort of say within those options, am I liking it? Or do I want to do something else? Or do I want to change what field I'm in? That kind of stuff.
Yeah, and the core programs will actually expose you to quite a wide variety of things. So, you know, in this course, we don't really expose you to much as like, here's what programming is. But other courses will expose you to different types, different products, different like aims.
Yeah. Tammy, maybe it might be worth you talking about your, because you've actually gotten further along in your journey than Shrey and I have.
I think things will just eventually fall into place if you just kind of go with the flow a bit. Like there will be times where you might stress out about, oh, I don't know what I want to do in the future. And especially like for me, I graduated from my degree like early last year, but I could say like the year before, I still didn't know what I wanted to do. Like I was freaking out about like, what do I do after my degree? But when you get to it, like things come up, opportunities come up, and then you end up, you know, just deciding on the spot. And it's like, oh, a few months ago, you might be like, oh, I never knew that I was going to do this, but like it ended up happening. So, yeah, like everyone else said, just focus on the experiences and trying different things and keep an open mind for now. And then when you get to it, you'll get to it.
And you've gone down the PhD route, Tammy. So it just goes to show that even within course admins and tutors, there's the awesome thing about computing is the amount of choice we have. We're in a privileged position to, I think, like and enjoy computing and to succeed at it, because the amount of choices we have it's not like, not every career is like this. So yeah, Patrick, whereabouts are you
I
up
can
to?
answer the student side of things and say that I really have no idea what I'm doing either. Basically, yeah, like I would add to the same kind of things. Basically just find out what you like, and as I think Shrey was saying, the core courses will give you a lot of that. And then just, yeah, find out what you like, do more of those courses. I've still yet to try a few things. I haven't done security yet. That's probably the next thing that I'm going to go do, like the 101 course of, and then see if I want to do more of. That's probably about it. Yeah, I've definitely got a few more years of my degree left. So
one thing which might be a good segue into the next question that's up there is talking also about people are asking about internships. One other way which you can get a good picture of like what you want to do is to be involved with student societies or personal projects. And so I'm going to say that both in terms of if you want to find out whether something seems interesting, if you can find a project online or as part of
100%.
CSESOC or with a group of friends, that's a good way of sort of getting a picture of like, oh, I enjoyed doing AI or web development or app development. But that's also a good place to talk about then internships. Who wants to start talking about them?
Well, Shrey, you're in one right now, aren't you? You're muted, by the way. I muted you.
Talking this whole time.
Sorry.
Everyone's ignoring.
Yeah. Because you're
Wow. Well, just talking about the internships, I just want to say somebody said that it takes a village of 5 people to run 141. It actually takes like 40 people. Like, let's take this moment to appreciate, like, Jake has done a lot of really hard work over this term. And then there's the admin team. There's also about 40 tutors who run all the classes. They help with assignments, help with the forums. Like, there's a lot of effort that goes in this course. And you should do your My Experience feedback to tell us if that's actually useful effort. Otherwise, that might just go away. Because if no one tells us health sessions are useful or forums are useful, then we might just stop doing them because the students aren't telling us how.
It all costs money.
But yes.
So
And
anyways,
I'm going to add in my the thing I always say about this, which is you might be sitting there thinking, I'm on 51 out of 100 in my course. I know I'm not doing 1511 again. Why do I care? The answer is because we have conversations with people who run other courses. The lecturers, Jake literally also runs 1531. So if he sees something works well here, it'll probably show up in 1531.
I'll probably have a few of you in T1 next year. That's a good point.
Anyways, on to internships. Good segue. Internships are, a lot of people think that you have to be like really cracked and like very good at programming to get an internship, and the whole point is like you just do lots of work. But it's actually the opposite. Most places expect that you know nothing but the basics and that you will do a lot of learning on the job. Like people are like, oh, I gotta learn this and this and this before I even apply for internships. You can apply with knowing like nothing. And Tammy's the first nodding her head. Tammy's done a few as well, so maybe Tammy, you want to speak?
Oh no, I just can relate to that so much. Like a lot of the companies, what they look at when you're interviewing is the kind of questions you're asking and the way you're approaching a problem. And when you come to things like, how do you approach it if you come to things that you don't know about? Like, I did an interview at some point where like I didn't really know JavaScript. I probably had like a few weeks of JavaScript experience, and then the interview was about coding in JavaScript, and they weren't really looking at my JavaScript skills. They were like, yeah.
A good thing I like to say a lot is that it's really easy to teach someone how to like do basic programming if they already know some programming, right? But it's really hard to teach someone how to work in a team. It's really hard to teach someone how to communicate. That sort of stuff is stuff that's invaluable to companies, right?
Yeah.
More and more, that's what industry's looking for. It's people that can work well in teams. They care that you know enough to be, dangerous, but they don't care exactly what you know. They'll help upskill you and pair you with people and support you, and companies getting better and better at it. But what they really care about more and more is how well you can just work with other people. So and that's where courses like 1531, the group projects, support you in those skills.
At least 2 or 3.
Yeah. There's many more. Yeah.
It's worth also saying from a practical perspective in terms of what internships actually look like when you're applying. The only thing which internships generally assume that you should check with that internship to make sure there's not something special is knowledge that we teach in a course called COMP1511. Now you can teach that yourself. You don't need to have taken 2521, but 2521 is sort of the basics of how programs, how you like structure data within programs. And there's almost always questions about something to do with searching or sorting, which is what 2521 covers. So practically that's one of the things that is useful. A normal path for an internship application is that you'll find the internship online, or your friend will tell you about it. They'll have what's called a hacker rank, which is basically just a short programming problem, kind of like one of our exam questions. In fact, in some cases, they literally take questions that we ask in our exams and ask them as interview questions.
Do they really?
And then after that, there'll be a series of what we call behavioral interviews, which are like talking to a person and discussing, tell us about a time when you did X. And then there's also some technical interviews, which are generally like kind of on a whiteboard. And they're really similar to what you might have seen in our tutorials, where you're like standing up on a whiteboard with some other people trying to figure out how to write a program with a tutor standing next to you giving you hints. Basically the same thing. It'll be a couple of each of those probably, and then maybe you get the job. That's sort of the application process. There was a question also about like what internships themselves are actually like. And maybe Patrick, Tanny, or Shrey, if you want to talk briefly about what they're actually like, that would be good.
I mean, it really depends per company. A lot of companies will just set you up with a mentor and a manager, and they'll get you to work on a project. And by the end of the internship, you'll have done a project or a few projects, or you'll get to work with your team on what we call tickets, so small items of work. It really depends per company. My internship is in most affection a project. So the first day, like, yep, by the end of this internship, you're going to do this. But other internships I've done, they're like, okay, you're just part of the team now, and you'll just do teamwork. You work in small pieces with us. I want to move on for internships because we've only got 12 minutes left, and there's a bunch of questions as well. But if people have more questions on internships specifically, put it on the forum, and we can definitely have some longer form answers to that, because I know that we don't really have much time to give like good stuff. In terms of one of the questions I wanted to answer was, once you've done 141, where do you go to next? 152 and 153 on 251, and why do you intend to choose that path? My answer here, and I guess the age-old answer, between 1521 and 2521, if you like C and you like the way that we talk about bits and bytes and how your computer works behind the scenes, and how can we do things like run multiple programs at once in our computer, right? We run like a browser and also your terminal. But when we're running programs, we can only do one thing at a time. How is that possible? COMP1521 really goes into sort of the underlying how your computer works. If you like the programming side of things, the algorithms like linked list, doing all that sort of stuff, COMP221 is more your friend. In terms of COMP1531, I think COMP1531 is a bit the step above those two, maybe just a little bit, because you're no longer just working by yourself, doing your own assignments, your own programs. The whole course is a group project. And Jake's running that, so obviously he can talk a lot more about that.
Yeah, it's the first software engineering course. So 1521 and 1511 are computer science. I see them more as computer science. I mean, both groups will take both, but 1531, we don't talk about the efficiency of an algorithm or we talk about which data structures to use, but we don't really care too much. What we care about is, can you actually use everything you know to work well with others to build awesome programs and projects and systems that people want to use. That's what 1531 is all about. So maybe if you feel like you're ready for it, you could jump in and take it. If you want to take another term learning more conceptual things, 1521 is a good next step. And then when you're ready, you can apply it to 1531. So there's no right or wrong answer.
Yeah.
Really, the other thing worth pointing out is if we let you into a course, we think you're ready to go into the course. There's no prerequisite for it or something like that. So,
and there's a lot of guides out there. I think Tom's even linked one in the chat. CSCSOC, the Student Society, has a lot of resources out there. I think some of them Tom, I, and Tammy have even written, which is extra fun. But there's a lot of resources out there, and a lot of students will have a lot of ways to help you with questions about that. Everyone's very friendly here at CSC.
Yeah. The other thing which is worth noting is that in some of those courses, you might go in and see somebody in 1531, let's say, who's got more experience than you, either because they were here, they're taking it in their second year, or they're taking it a term after when you started. don't worry if there are some people there who have more or less programming experience than you. Everyone's on their own journey, and I know that kind of sounds like one of those things that everybody says, but it's really true. You will find that like 2521 might be easier if you've been programming in 1521 for an extra term, just because you've got more programming under your belt. It's like speaking a language. Like you spend more time speaking the language, you'll do better. So don't worry about the fact that you might not be fully the same as everybody else. Totally fine. I posted in the chat a link to the CSE pathways, which kind of shows starting at 1511, like what other courses you can take. That might be useful to
So I've got a question for you all. Some people are asking, oh no, teamwork isn't my best skill, it's my weakness. How do you get better at it? Tammy,
Patrick?
Start off?
Yeah.
Or Patrick?
Teamwork? Well, there's group projects, of course. So 1531 is probably done the most for my teamwork in terms of courses. I guess that'll be the main one from the view of like computer science and from like actual uni courses.
Yeah.
Other than that, just any kind of roles that you have, so volunteering or working, or any other uni courses that have group projects. Like all of that experience is going to be helpful. Although computer science specific ones, so I think in 1531 you'll still be doing like agile programming, I imagine. So things like that are going to be much more computer science specific.
Yeah, I guess the idea is practice. I mean, just like programming, there's no difference.
Yeah.
You are exposed to more people, that you see how people think and how to navigate people and things like that, and you just get better at it. But it's something that everyone constantly works at. So just, really, if you're just kind, it'll be fine. Same with 1531. If you're nice, no one's going to have a problem. It's when people aren't that you have problems.
Yeah.
Shay?
I was going to say, and like, there are so many opportunities out there for you as well outside of courses. Like, if you're into like CSE Soc, they have the hackathon, they have a personal competition. Other societies have case competitions. They have like social nights. They have like hack nights where you just get together and try to make something together. And it doesn't even have to be computer science stuff either. You can do like hardware stuff. Like if you like woodworking, go to the makerspace, make some friends, do some stuff, right?
There's the coffee club, honestly, there's heaps of stuff. Yeah.
Exactly. Like that stuff actually belongs in a resume. If you make something decently impressive, that can go on a resume because it shows to an employer that yes, you have actually worked in teams before. You are able to communicate. You're able to break things down into small problems. That is what they're looking for, right? These projects don't just have to be comp sci projects. They don't have to just be comp sci skills. Like the comp sci skills can be taught. In fact, some companies will literally put you through a boot camp for like 2 to 3 weeks, teaching you how to do certain programming stuff, like as your internship starts. Assuming that you've got like zero knowledge. I think Tom, you've had to do that, right?
Yeah. Definitely, some companies will they will assume that you know very little of what they're doing, and they'll sort of start you from scratch. The other thing which is worth noting to what Shrey said about joining other societies and stuff is joining societies is not only good for developing your skills, but also having a professional network is like genuinely one of the most important things you can get out of university. Like the courses are great, and I don't want to say anything bad about the courses, but like the things that I will remember most from university are not sitting through lectures. It'll be the times when I was working on a problem late at night with some friends, or when I was on a road trip with people. Not only is that much more fun and sort of that sort of thing, but also as you go through your degree, having other people who you can reach out to and say, hey, have you found any internships? Like I've got friends who found internships because their friends got an internship last year and they got a recommendation. Or things like, oh, hey, which courses have you taken? And you might find a course that you love because your friend took it and they liked it. And even better, 5 years from now, when you're outside of uni, you've then also got a network where if you're looking to change jobs or you're looking to change skills, you can reach out to someone and say, hey, how we were mates in uni or we worked together in this one course. Let's chat about this thing.
Yeah, I think everyone's fervent nodding means we all agree.
Yes.
Which I think answers Matthew's question. Would you recommend starting your own projects? I mean, absolutely. As soon as you feel ready. Yeah. That's what separates the best programmers from good programmers, like all of you will be and are. But the more you do it, the more edge cases you'll come across, the more experience with what works, what doesn't work. It's just experience what makes a good programmer really good, I think.
One tip which I often share for this, because I get a lot of people asking me like, oh, how do I find things to work on a project for? There are two good ways that I know of doing this. One of them is that there are websites online that have a list of projects that are looking for people to help. So one's called like goodfirstissues.com. If you Google that, you'll find it.
I think GitHub maintain their own list as well.
Yeah, GitHub definitely has some as well. That's really good, because if you can find a community of people who are all working online with people who are better programmers than you, or at least have more experience than you, that's how you learn so much. Like, one of the things that really got me to be a better programmer was the fact that I was working with people who had done more programming than me, and I learned a lot from that. The other thing which I often recommend is to keep a little list in your head, or even like in a book, whenever you see an idea where you're like, oh, I wish I had something to do this thing easier. Even if it's as simple as like, I've got all my lecture videos, I wish I could just download all of them. Or I've got, I've got to keep track of all my tasks. I wish I just had a list of all my tasks. Like, simple things like that. You can build yourself a tool, and if you use those tools and you sort of increment them and tweak them a little bit and make them better, you learn so much from that.
Yeah, absolutely.
I mean, that's so you go, Patrick.
Yeah, like taking problems that you have, or just like little things, and you'll kind of see more of it as you go along. As you see more things that get automated, you can look at a problem and be like, oh, I don't want to spend 10 minutes every week doing this. I want to spend, well, I don't know, it might end up being like 5 hours doing it 1 week. But even minus the time you save or time you don't save, the experience of doing it can be quite fun and helpful. Back when I was budgeting more, I was making a program because I just wanted to see if something I wanted was on sale at Coles or Woolies, and where.
I mean, yeah, Tammy, Tom, and Trade. No, we try to do that all the time with 1511 and making things a bit easier.
I was going to say, the whole of this course is automated because, like, there are things that take us so long to do that we've just written a program to do it for us.
Yeah.
Things like auto marking, right? Like that. Like, the way we do performance marking is all script based, because if we had to do it by hand, it would take us like a month, I think. With 1,000 students, probably months.
Sure.
Yeah.
That's a good question you've highlighted, Jake.
Yeah. So I always don't know how to pronounce Summer Guida. What kind of projects do people actually do in internships? It's not clear what's the day-to-day. I mean, yeah, I think Tom said it before. It completely depends on what you're working on, who you're working for, and the team you're working in. And what you define to be giant. I mean, Google's giant is different from other companies' giant. So it's hard to say. Yeah. Who was that?
Can I make a suggestion? If people are comfortable with it, the people who've done internships in this call or who have worked, maybe it'd be good to spend like 30 seconds talking about like a day, what a day was like at that job.
And I can tell what my day today was.
Yeah, sure. Sorry. Like,
you're at Atlassian, right, Trey?
Yeah, so I'm at Atlassian right now, which is one of the big hires for CC students in Sydney. Atlassian, basically, they have a bunch of product suites. They write software for other companies, basically. And so I'm in the search team. And so what I do day to day is I run a bunch of experiments. And these experiments basically see, like, if I change how we can use search, will that result in users being able to search better or worse? So, for example, if I have like more filters, more options, more UI stuff. So literally today, I implemented a new feature for the search bar, which allows you to type certain things or click certain buttons that will change how you search. And now tomorrow I'm going to be seeing with the data analyst if that's going to actually create big impact and how, etc. But in terms of the actual programming I did, it's literally all like JavaScript, React. It's like website stuff. That's the stuff that I'm doing. But yeah, there's a lot. It changes all the time.
Yep. Tammy, do you want to talk about what a day in life of a PhD student is?
I guess it's less relevant to internships, but I think just jumping to the internship thing, I'll throw out the PhD. Just jumping to the internship thing. Like, if you are interested in some company and so on, like, there's a lot of site visits. I don't know if we mentioned that, like site visits that CSE does and so on. Like, highly recommend you to go to those site visits where you get to go to the company and actually talk to people there, and then so specifically for the companies that you're interested in what the projects and whatnot there is like, and what the day-to-day life of them are like.
Yeah.
And friends around you.
And you might, exactly. Okay, let's see.
One other thing which I wanted to note on internships, if I may, Jake.
Of course. Yes.
I don't want to take time out. So over internship at a company called Optiva, which is like a high frequency trading company, and they're quite different to a lot of the other companies that you'd see who work on web stuff. They do a lot more sort of fast programs written for hardware. So in things like C, we're programming a lot in a language called C++, which is kind of like C. One thing which is really interesting, which you might not expect though, is that only about 50% of your time is spent programming. So, there'd be mornings where I'd sit down and write a program or write part of a program that was looking at data. A lot of what I was spending my time doing was going to meetings or learning from other people, or even talking to other developers who I'd written code, and then I send it to them and they come back and say, oh, you could improve this thing, or this will make it faster, or that's a problem, and having those sorts of discussions. So I think a lot of people have this impression that CompSci is like the one dude sitting in the basement with like his Cheeto stained keyboard writing on, by himself. It's not like that at all. Like, most of your time will be spent talking to other developers, learning from them, working collaboratively. For sure.
And the more senior you get, the more it's just meetings. That's pretty much how it goes.
With regards to losing your files, you'll still have access to CSE and SSH and or VLab, etc., as long as you're a CSE student. So if there's a term or two where you're not doing any CSE courses, you might lose access for a bit. But when you come back in another CSE course, you get your files back, etc.
Yeah. So if you're doing this as a Gen Ed, really want them, just download them.
Yeah, exactly. If you're doing this course as a Gen Ed or elective and you're not doing any more comp courses, download your files now, because you might lose access within the coming few months.
Yeah, it's always fun a few years later, I'm sure you all do this too, and you look back at your 1511 and you're like, oh my god, that was what I did. I was awful, but at the time you're like, oh, I'm the best programmer ever. So.
Can I suggest a fast question round before we finish, if we're going to finish up soon?
Yeah, that sounds good.
So I'll target these questions at people if that's all right with you, Jake.
Yep.
Jake, can you give your take on 1531?
1531, a lot of teamwork. Get over the fact that you'll be put in groups. It's going to happen. Learn to work with the groups. You build an awesome project. It's a lot of fun. We'll help you. And all your questions about internships, 1531, I think, is the first step at answering some of them, because it really is very realistic. So 1531 is really good.
Tammy, how do you put code of your programs on a resume?
Code of my program on my resume. I don't even think I have anything code on my resume. You just the closest to code is like your project section.
Link you
and where would you host your
project? Sorry?
Where would you host your projects?
GitHub.
GitHub. Cool. So there's a website online.
Keep in mind, this is projects and not your assignment code. You put your assignment code on GitHub.
Don't share your assignment code.
You'll get
we'll find you. We'll come for you.
Shrey, are extra certifications worth getting? Like Microsoft for promoting courses with an exam?
No.
Wow, that's a
no. Like they're genuinely not. Like
I actually agree with you.
Won't care. Yeah. The only exception is maybe if you're going into like system administration and you're looking to sort of manage computers and not like do programming, then no, it's not really useful.
And maybe some cloud stuff.
The only thing,
some cloud stuff.
Yeah. The thing I'd add to that is like certifications and courses are a means to an end. So if you want to learn something, having an exam at the end kind of helps with like you studying it. That might be good, but the certification itself won't get you anything. It's only the fact that you know it and you can demonstrate you know it in the project. Going through some of Shrey's questions, which are good. Patrick, favorite course?
Favorite course? Honestly, 1511 holds a special spot in my heart for being the one that convinced me to add computer science to my degree. Other than that,
you're not fired. Congratulations.
Yeah.
Was that sorry?
You pass.
You're not fired. Yes.
Yeah.
Good to know.
It's worth mentioning Ben is in the course chat. Ben is the other course admin.
Yeah.
He asked us all to promote OS, which is COMP1511.
So Tom,
OS.
let's do everyone's favorite courses. What's your favorite course, Tom?
You want to start with me? COMP2041. I'll steal that from everyone else. COMP2041. Writing programs on the command line, and it's a course I literally use every day.
Very Unix heavy stuff.
It's like what we were looking at earlier with Jake trying to... Well,
which, by the way, one of the programs just wasn't compiled correctly, so it was working the whole time.
So COMP2041 is about automating stuff, basically. So everything you do now, imagine if you could write your own version of like Autotest. You don't have to keep writing in stuff over and over again. That's basically 241. My favorite course, COMP1511, which we're running for the first time next term. Me, Tom, and somebody else will be running this course. So if you're interested in learning about Rust, you should do that course, and also like the decisions behind Rust, why Rust is such a popular language. Do that. Otherwise, COMP3141 is really good, and so is COMP6441.
Wait, if I get to say more than one course, I kind of have to also promote the course which I teach, which is COMP721. So COMP6721 is all about how you like write programs and prove that they work and use those techniques to write better programs. So it's a great way of learning how to program better. Tammy, now you can. What's your favorite course?
Guys, do a PhD. No joke. My favorite courses, I think it's still 1511 because it opened up the doors to programming, and like that led me to all my other opportunities. Like I didn't know what programming was before 1511, and 1511 gave me so much memories and so much tears, but it was good when you look back on it. So yeah, 1511.
And then on behalf of Ben, I will say that Ben's favorite course is. I'm so tempted to like say a joke course, but Ben's favorite course is operating systems, COMP3121. It's all about how you can build your own operating system, so build something like Linux or Windows.
3121 is algos.
Oh, sorry, 3231, excuse me. I always get those two confused. COMP3231. And Ben would also recommend COMP9242, which is the answer to what's the hardest course at CSE, which is Advanced Operating Systems, where you build your own operating system in 10 weeks.
Sounds awesome.
Would not recommend. People basically compare it to a full-time job, having doing that one course. So be careful with that one. But OS itself is actually pretty chill. Like OS is a pretty chill course. In my opinion, it should basically be core for most people because it's very useful. In fact, it is core. I think for Senge. No, JK, that's a lie. But yeah.
Yeah. Well, no one asked me, but my favorite course that I studied was probably, we had a course called, I didn't study at UNSW, but we had a course called concurrency or concurrent programming. Probably maybe sort of touched on in OS here, but that's a mind-bending.
We have distributed systems, but I don't know when that's returning. Maybe next year.
Yeah. Okay. Yeah. So yeah. It's stuff like that. So mutexes and semaphores, and so we're building the low-level mechanisms that make a threaded program safe, and that's a lot of fun. Okay, what are we missing here? Any questions? Last-minute questions? If you need to head off, of course, head off. We can hang around for a couple more minutes to wrap up, of course. But I mean, the fact that there's so many, it's worth saying, not all universities are like this, where there's so many awesome courses that people can't even agree on 5. I mean, really, it's really cool. So you can't go wrong. You're gonna have so much fun.
I'm really tempted to ask what worst courses are and then just end the stream right now.
We're not doing that. Yeah, if you're heading off, thank you for the 10 weeks. I'll be teaching 1531 in T1 next year, not T3, but you'll have Hayden, who's excellent as well. So it's going to be a great choice no matter what you do. But thank you so much. It's been an awesome 10 weeks. You've all been awesome. We got through our crazy week 1 lectures with our invasion of the bots. We got through linked lists. We got through it all. Thank you all so much. Did we miss any last? We'll make a thread on the forum to continue.
Yeah,
any questions like this.
Yeah. Also worth noting for exam stuff, if there's any question about exam, put it on the forum. We're all literally watching the forum like hawks these days.
Yeah.
If you've emailed us anything and we haven't replied, we haven't missed you. We're just getting a lot of emails right now as the term ends. So please be patient with that. We'll be sending out more emails about the exam details closer to.
And it's
the
actually
end of
the week 11 revision classes. Is the schedule public?
Yep.
Tom?
Yes.
Yes. So I was about to say that I've put the schedule on the forum. There's a question about more information. So those revision sessions are pretty much an opportunity for you to work through revision content. They're kind of themed. So there's 2 on arrays and strings and 2 on linked lists. You can kind of bring whatever you want to them. we'll have some suggestions there for like relevant revision questions that you can work on. And obviously there'll be tutors there who you can ask about particular things, tutors who can give you explanations of things if they don't quite make sense. But the intent for those is it's kind of partially self-directed, and then there's some sort of hints from tutors. So there's not too much more information to give about them. The online sessions, there have been events created for them in the 1511 team, so they'll be on Teams. And I'll also mention we're planning on putting out some revision videos, but I'm not going to say too much more about that because they're not ready yet. So keep your eye out if you're looking for revision content.
Yeah, exactly. Yeah, the general teams, Joel. The course-wide teams. The exam is on the 12th of August at 1 p.m. for most students. Some few will have it at 9 a.m., but you'll know if that's you. Yeah, next Friday.
And again, we'll send you an email confirming like what day the exam is for you, what your time is, if you have any extensions, like all of that will get you an email, and we'll sort it like well out.
Yeah, so please keep your emails active. Yeah. Set up notifications.
Yeah, and we'll put a thing on the forum as well saying you should have received an email. If you haven't, let us know. But yeah, please don't email us after the 12th being like, hey, when's the exam? We had a student do that last term. It was a bit stressful.
It happens. Don't be afraid of it though. Maybe question 8, but
the exam for the most part is not like we're not trying to trick you, right? Like no one has ever failed the hurdles who has not like passed one for one, assignment 1, assignment 2, right? Like if you've gotten past stage 1, you're doing great.
Yeah, if you're engaged, if you know what we're talking about, you're completely fine. We promise.
Yeah.
For sure. And if you are really genuinely worried about it, do reach out to us, like post on the forum privately or email us. We can have a chat with you. You can reach out to us in the revision sessions as well. Yeah, for sure.
Hey Jake, do you want to attempt question as a bonus stream?
All right. Well, if you do my experience, we can do whatever you want. I'll sell out. I don't mind.
You know what we should do, Jake? If my experience gets 75%, you do a question 8 live stream.
I'll do a coffee machine. They want to see my coffee machine, so we'll do that, and I'll do a question 8 live stream. We're at 39% right now.
60%, 70%, 80%.
We're at 39.
What milestones we got, Jake?
We need a we need a what are those? What's those things where you pay money and you unlock the tiers?
We'll put something on the
Jake's Patreon.
Yeah, Patreon.
Yeah, if we're doing a question 8 session, don't worry, the tutors will be there watching. We'll make sure to remind. You're missing a semicolon. Oh, we got him.
No, but yeah, we're sitting at 40%. It'd be awesome if we could get it higher. So if you haven't done it yet, please do it. Although I'm sure many of you have already done it. And there's a few labs still coming up. So
otherwise, we'll start putting pop-up ads on the course website. During these. Flashing red, purple, like my experience.
Okay, well, we should leave it there. Thank you all so much. Again, we can't stress enough how many people it takes to run a course. Even on top of all the tutors and the course admins, it's people in the school, the support the school.
People students on the forums who have saved us time.
Daniel Chen, shout out to you. You've
Daniel.
been very helpful. But many others of you.
Almost every post.
Yeah, Daniel's been very good.
Yeah.
We see all. Okay, thank you everyone again.
Oh, wait, one more thing. Tutoring applications will be out soon.
Yes.
If you're interested in tutoring this course, you can. Like by virtue of finishing the course, you're able to tutor the course. We have many tutors who are just on the course and then have done tutoring. So that email should come out today, I was told, but I imagine that means tomorrow. So that email should be out soon, and we'll put an announcement out when that's out. So if you're interested in tutoring this course and joining the team of tutors, please have a chat to us if you want interested. Actually, don't have a chat to us. There'll be a form which you fill out. But if you want to know what it's like, then you can have a chat to us. Yes.
Yeah.
But just on that, it's worth noting we get lots of applications for that. So even if you're not sure, like if you're like, oh, I'm not sure I could tutor it, still apply, because what really matters for tutoring isn't like whether you know everything. You don't need to have had an HD to get a tutor to answer that question.
Only a pass.
All that matters is, number 1, that you are able to teach things, and number 2, that you're passionate and you actually want to teach things. If you've got those 2 things, the rest will follow.
And number 3, that you did your My Experience survey. We do need that. That needs to come through.
But yeah, so I've tutored courses where I got a credit.
Yeah. What if you're not a CC student? I don't think that matters.
That's fine.
Yeah.
We have tutors who are not CSE students who have done the course.
Yeah.
Yeah, for sure.
Okay. All right. Well, let's leave it there. We've gone 15 minutes past, but I think that's okay. Thank you all so much. Was that not anonymous? I don't know what that means.
No,
My
sorry.
experience is-
My experience
Yeah.
isn't
Oh,
on-
no, it's a joke. I'm joking.
Yes, if we don't get 80% my experience, we're not hiring.
Yeah,
any
well, that's
tutors
it. We're
next term.
cancelling the course.
Yeah, true.
It's all over. Yeah. All right. Thank you all again
Gonna
so
hold
much. This
my
was a
phone
really
for
nice
a
way to
second.
end off all the lectures. Good luck to all of you. I mean, everyone. Good luck to everyone. Shrey, Tom, Patrick, Tammy, all the lecture chat. I'll miss the lecture chats. It's been really good. All right. Good luck with all your
See you,
courses.
everyone.
Good luck with exams.
See ya.
We'll see you around.
Yeah, everyone.
Everyone.
Good luck.